So in our first lesson, we learned about your triangles that have those special angles. So sometimes you see those referred to as special right triangles or special angles. They're just very common. So we learn the ratios of those sides or how they relate to each other. So this is our 45, 45, 90 triangle and a 30, 60, 90. We're going to write the trig ratios for the angles. So we'll do sine, cosine, tangent of 45 degrees, sine, cosine, tangent of 30, and then of 60. Just as a refresher, if you remember, your 45, 45, 90 triangle has its isosceles. So you have two congruent legs, and the hypotenuse is square root of 2 times the length of your leg. So square root of 2 times 1 is why that's just a square root of 2. And what we did is just kind of for a standard triangle is we said that these side lengths were 1 and 1. We could have, said 5 and 5. This would have been a 5 root 2. Found our trig values. All the trig values will be the same because all 45, 45, 90 triangles are similar. So sometimes it's easy just to look at a reduced version, 1, 1, and then root 2. Our 30, 60, 90, we know that the hypotenuse is twice as long as the short leg. Short leg is opposite of your 30 degrees. So if our short leg is 1, the hypotenuse is twice that. So 1 times 2 is 2. The third side across from the 60 is the short leg times a root 3. So 1 times root 3 is why this side is root 3. Okay, now let's go ahead and find our trig ratios. So for the first 45 degrees, you could pick either 45-degree angle. You will get the same trig ratios, but I'm going to choose that one. And now I'm going to label the triangle for that 45 degrees. We've got our opposite side over here, our hypotenuse, and the adjacent side. So sine of 45 degrees is the opposite over hypotenuse, so 1 over root 2. Well, we're not going to leave a root 2 in the denominator, so we do rationalize on this, and we get a root 2 over 2. So sine of 45 is root 2 over 2. Cosine, of 45 degrees is the adjacent over the hypotenuse. Our adjacent side is 1, hypotenuse is root 2. And we might notice that we just had a 1 over root 2. When we rationalize it, we get this answer. So we'll just borrow our work from above and say, well, we know that's a root 2 over 2. All right, last we have tangent of 45 degrees. That is the opposite side, 1, over the adjacent side, 1, which reduces to 1. All right, now we're going to move on to our 30-degree angle. So let's find the sine, cosine, and tangent of 30. So if I go to the picture, here's 30 degrees. I'm going to label opposite side is 1, hypotenuse is 2, and adjacent side is that root 3. So sine of 30 degrees is the opposite over the hypotenuse, so 1 over 2. Cosine of 30 degrees is the adjacent side over the hypotenuse, so root 3 over 2. And that's okay to have your radical in the numerator, so we'll leave that one alone. And then tangent of 30 degrees is the opposite over the adjacent. So 1 over root 3, well, we're going to rationalize that, and we'll get a root 3 over 3 for our tangent function. All right, last angle we're going to do our trig functions for is your 60 degree. I'm going to go up to my picture and erase these labels because now I'm switching angles. Now we're going to look at the 60-degree angle, which means the opposite side is now the root 3, hypotenuse stays the same, and adjacent side is the 1. All right, so sine of 60 degrees is the opposite over the hypotenuse. Cosine of 60 is adjacent over hypotenuse. And tangent of 60 is the opposite over the adjacent, so root 3 over 1, which just reduces to a square root of 3. Okay, so those are your trig functions for your special right triangles. One thing you may notice, some of those ratios are kind of repeating themselves, right? Like here's a 1/2, well here's another 1/2. Here's a root 3 over 2, here's another root 3 over 2. Here's a root 2 over 2, here's a root 2 over 2. So that's, if we notice that, that's going to lead us into part B. How are the sine and cosine of complementary angles related? Well, anybody remember what complementary angles are? Complementary angles will add up to 90 degrees. When we look at our right triangle, we know that all three angles add up to 180. Because it's a right triangle, one of the angles will always be 90, which means 180 minus 90, you've got 90 degrees left for the other two angles. So angle A plus angle B will add up to 90 degrees, which makes angle A and angle B complementary. So the question is, how are the sine and cosine of complementary angles related? Well, let's find the sine and cosine of angles A and B. So sine of angle A, here's angle A. We have the opposite over the hypotenuse, so A over C. Cosine of angle A, so we're still on angle A, is the adjacent side B over the hypotenuse C. Now let's look at sine of angle B. So we switch gears, now we're down here angle B. The opposite is side B, hypotenuse is C, so B over C. And then the cosine of angle B is the adjacent side A over the hypotenuse C. So what we notice, here's an A over C and here's an A over C. So that means the sine of angle A is equal to the cosine of angle B. And we probably already noticed, or also noticed, that we had a B over C and another B over C. So the sine of angle B is equal to the cosine of angle A. So what we can sum up with this is the sine of an angle is equal to the cosine of its complement. And vice versa. So the sine of an angle is equal to the cosine of its complement. Vice versa, the cosine of an angle is equal to the sine of its complement.